All righty. What is a repeater? Okay, now in this picture that I was showing you, there's a typical repeater on 440 megahertz, uh, and this shows 100 hertz CTCSS. Uh, Input frequency to the repeater of 442.725. The CTCSS tone is sub-audible, it's supposed to be. And some people have them turned up a little bit too high on their repeaters and you can hear them. And that is the tone when you program a repeater into your radio, that you have to have that tone there so that they can be, and here's what it's for. It triggers a relay in the repeater, essentially, and lets it go into the retransmit mode. So you have to have that tone coming in. And now little guy here is walking around, and the car is the guy he's talking to. They're on opposite sides of the mountains. They need this between them, and that's what it does. And the offset, you'll see 442.725 is what he's transmitting out of his radio, even though his dial in his radio says 444.725. And those of you who've used ham radios in this, a ham radio, not a Motorola or any of the other ones, but the ham radios will always show you what transmit frequency you're using. And that's and you're listening. That is, it shows you your listening frequency. And then when you key it, it'll show your transmitting frequency normally. And the repeater transmits on one frequency and listens on the other. And then some of them will rebroadcast that 100 hertz tone if that's what it is. The CTCSS tone is also known by some other names. Motorola was successful in marketing as a private line, where they called it a PL tone. They called it private line. GE called it quiet channel, QC tones. They all had their own names for the same thing. It was marketing, that's why, but obviously the marketing of Motorola was stronger, and that's why we have the PL tone as what we all know it as. Now we'll come back to this picture in a little while and learn more about it. Now let's go to a little bit of the basics of it. As the name implies, an FM repeater does repeat your radio signal. It's just a ham radio station that has been designed for the special purpose of retransmitting your signal instantaneously as it's received. So when you key it up, you're not hearing. Well, it's called half duplex, I guess. Well, it's I won't get into that. But anyway, it's designed so that it will retransmit your signal. How does it do that? Well, and here's a little more of it. Typically, an FM repeater station will be located on a high position, maybe a hill or a mountain or a sizable tower on a building or a tall building. And a repeater station will also transmit with a much higher power than the operator uses on his little Bowfang. So, or whatever handheld radio you're using at the time. So the idea is now your little 1 watt radio has the power of whatever that repeater is. Most of the times you're going to find them in the 30 to 50 watt, 60 watt range coming out of the repeaters. And the idea is that so that the receiver on the end gets a better signal than he might be putting in, because it's usually a handheld and you're at a disadvantage anyway, so it helps you to be heard better. The FM repeater's relay of your signals retransmitted over a much broader area than you could ever achieve, whether you're mobile or handheld, than you could do from your station alone. And the fundamental benefit of this is that the operators who are geographically separated in significant distance can use, hold on, got to admit one more, these late people. Anyway, the benefit is that the operators who are separated by a greater distance can use the repeater to make contact with others when the simplex operations aren't really feasible or practical due to the separation or the terrain. And And when those of you who were involved in the simplex drill that was done here for, I guess that was more like the Skywarn, but that's what it was all wrapped around. You got to see that the people you heard on the repeater, you couldn't hear them when you were on simplex in a lot of cases. And that was the idea, to give you a feel for what that was like. But that's what a repeater does. It fills in those gaps where you couldn't achieve otherwise. Cool thing about a repeater, they use published frequencies that don't change. Well, they could eventually, but for the most part, they don't. They're published, and they groups of amateur operators will often use the repeater for nets, on-air meetings at prearranged times. You know, like, hey, Joe, meet me on the repeater at 5 o'clock. Okay, so that's kind of why, or a specific purpose or a topic of interest. And you'll find a number of nets in the Harrisburg area at various times throughout the week, and these are what that's for. And nets on repeaters may also be convened by amateur radio emergency response agencies like what we're training for. And they coordinate emergency aid efforts across a broader area within a repeater's range. And 145.11, as we use for the most part here when there's an emergency, and 147.075 and 448.075, they're the key ones and listed as their primary frequencies for emergency because of their range. They are much higher locations. Ellendale Forge, where those three are set, is north of Harrisburg, maybe 10 miles, but it's on the highest elevation and the highest towers. That's why they work so much better. And if you haven't used them, by the way, the 448.075 has tremendous range. Everybody goes to 2 meters all the time. Try some of the other ones. Your radios will do them for the most part. But 448.075, you'll be surprised at the range that has. It also has some extra receivers on, so does the 145.11 here in Harrisburg. So anyway, the on-air meetings are prearranged and so forth. So that's one of the uses. The most common type of repeater is an FM voice repeater using VHF or UHF frequencies in the ham bands. But there are different other modes too, including single sideband. And there are some. There was a time repeaters were AM before the advent of the proliferation of FM equipment from the commercial bands that came into our 2 meters and 440 range. But the repeaters, they can be used in single sideband or digital modes. HF frequencies as well can be used as repeaters. But we're going to stick mostly to the FM. Really, that's what we're going to be using. And the commons are VHF and UHF FM repeaters for voice or phone mode. There are repeaters for digital modes of various kinds that are becoming more popular, but we won't get into those for right now. And how it works is kind of simple. As an FM repeater receives your signal, it must retransmit it on a different frequency. Here's why. It can't retransmit on the same frequency that you're using to reach the repeater, because it would be because of a feedback loop in which a repeater's receiver would hear the transmitter and it wouldn't work. So how do you accomplish that? They use 2 separate frequencies to do it. Now, the difficult part, the way the 2 meter band was finally organized by the ARRL, is they have them 600 kilohertz apart. Now, keep in mind that when this was all done, the ARRL was very used to HF frequencies where you could put 2 people 3 kilohertz or 6 kilohertz apart and you wouldn't hear one another. So in their minds, they thought 600 kc apart, that's fine. In reality, with these radios, because of that's kind of close for a typical VHF radio. when the first repeaters came out, they were much further apart in frequency. Everybody was experimenting with everything. There was one on Research Summit that had a transmitter there and a receiver in another location. And they were even using really high power. That one had a kilowatt. Imagine 1,000 watt. They heard it in Manhattan, and it's documented that Irvin Nissel, who owned a repeater, was in Manhattan talking back to people here with his 1,000 watt mobile back to the 1,000 watt repeater. And it was a lot of fun until they came out with better ideas. And then the frequency for 2 meters, 600 kilohertz offset. And you'll see that when you're setting up a radio, it asks you for the offset. And now on the 440 range, those are 5 megahertz apart, and that's a much better split. And why am I saying that? Because as we get into the pictures I have here of duplexers, you'll see that with a 5 megahertz split, it's much easier to make a radio transmitter and a radio receiver not hear each other or not even see each other, because these repeaters use the same antenna for transmitting and receiving. And if you've ever given it much thought, if you were to take your radio, take a cable from your radio and connect it to another radio and put a T connector in it and hook it to an antenna, if you were to key that radio, it would blow out the front end in the other radio. So that's what we're getting into here in a little bit. So to receive signals from a repeater uses, there's another frequency. It's used to retransmit the signals. And on the 77 centimeter band, for example, in the next graphic that I show you, it'll show these repeaters. Now, there's the one we saw before. Each station monitors a repeater using the frequency, on this case, of 447.725. When a pedestrian with an HT radio operator transmits his signal, and you'll see in the red arrows, is his signal coming from his radio to the car. And it retransmits his signal on 442.725. So that's so the guy in the car can hear him. See, he's listening on the output of the repeater, but he transmits on the input and the repeater switches it. We'll get into that in a little bit. The receiver receives a repeater and retransmits it on 447.725 to be received by another station monitoring that repeater frequency. Any other station, such as the SUV in this case, and the mobile, he operates exactly the same way, retransmitting the lower frequency to the repeater, and the repeater transmits out on the higher frequency. Did I confuse anybody yet on that? Okay, let's get into the offsets. In our example, we saw that the difference between the listen frequency of 447.725 and the talk into the repeater frequency is exactly 5 megahertz. That's the difference between the repeater's paired frequencies, and it's called the offset or the shift. Standard values for the repeater offsets are established for each band in ham radio, but these are only recommendations. Most repeaters follow the standard offsets, but not all of them. In fact, there's one in, I believe, let me think what mountain. It's over going toward Carlisle, or maybe it is in Carlisle. On the 2 meter band, it's 1 megahertz apart instead of 600 kilohertz. But here in the amateur band's standard offset for the 2 meter band is 0.6 megahertz or 600 kilohertz. And here's your example: 147.375 and 147.975 with a plus, which means that's a positive offset. In a 70 centimeter band, 5 megahertz offset, and you can see the examples they give there. And the 1.25, or we call the 220 band, 220 repeaters, which there is one in Harrisburg, and I'll put a pitch in for that. When you're buying your Dauphin radios, they offer now a tri-bander, which also has 1.25 meter band. And those are, a 1.6 megahertz split on those. So you run into that if you get a chance to try it. Of these bands, we're so used to 2 meters and what it covers, you'll find it each has a different coverage, but you'll also find that the 220 band really covers well because there's very little RF noise in them. Now here's your standard set of CTCS tone, which is continuous tone coded squelch tones in hertz, or as us old guys call it, cycles per second. But it ranges from 67.0 up to 254.1. You'll find in our area, the 7.6 repeater uses a 100 hertz tone. Most of them use 123 cycles. And there's others, another one like the 145.1 repeater is 131.8. So you'll run into these, and as you go through your radios and program, it'll tell you what the tones are. And we covered about how to program a radio a couple weeks ago, and that's how it is. Repeater coordination. You would think, okay, it's ham radio. I can put a repeater up anywhere I want to and on any frequency, and it's cool because I don't hear somebody, so there must be an open frequency. Not always the case. So there are people that actually coordinate these efforts, and this grew out of commercial radio because in commercial radio, there is, if somebody's trying to send me chats, I can't see them. I keep seeing it blink up in my my area here somewhere. I'm trying to get them off the screen now. They're up there. So anyway, the in the commercial world, I learned about this long before I was into ham radio. But the commercial world, business repeaters were set up, and they had a coordinating company that their job was totally to coordinate and recommend repeater pairs to us that we did in commercial radio. And then when I get into ham radio, that's why they are there, because there was so much confusion and everybody's putting repeaters up in pairs that didn't exist that we don't see anymore. And they decide to coordinate them. They come up with a band plan, and then there's a regional coordinators that actually select the repeaters. The regional frequency coordinators are selected by the operators and organizations whose stations are eligible to be repeaters. And we're in a group in this area that covers New Jersey and Pennsylvania and Maryland. And the coordinator recommends the repeater pair frequencies and other station parameters to help avoid interference. Those could be the frequencies, who you have to change your antenna so that you don't interfere with somebody, and what tones to use on them. Maybe even what power level you're allowed to use. And the frequency coordinator may itself be a group of or an organization comprised of repeater operators or club representatives. And that's exactly what we have here. And we have one of the members of the repeater committee for Repeater Coordination Council lives in our area, and you'll hear him on the radio, but he's I won't mention Kevin's name. So anyway, on the air protocols. Now there are a couple different kinds of repeaters that we have. There are wide area repeaters and some that are just kind of local and so forth. And the wide area repeaters, they reach very wide areas. And we have a couple of them here that are linked with other places. And they may have a policy of priority only traffic, no rag chewing. That means like getting on there and just talking. And that is, the repeater operators wish to keep the repeater available for long range communications. And they consider it more of an important nature than checking up with the health of your friend's cat in the midst of an hour-long idle chit-chat and all that. One of them is it's on the 440 band, and it's over in Summerdale. It's if it's still there, it was linked in with the Penn State group, and it covered like 4 states, which is kind of cool. But if you would get on it and start just blabbering, they would come on and say, hey, can you take that to one of your local repeaters, because there's a lot of people trying to use this. Now, the other things in protocols, there are some repeaters that may be designated specifically for extended talking, yucking it up, and generally having fun on the air within the Part 97 regulations. And there are others who want to be a little more formal. And I'll use 7.6 as an example. Let's see where we fit in. We'll compare it to another one. There's the 145.21 repeater is a privately owned repeater, not a club owned. So they can set their own rules, and actually any club can too. Their rules over there, it's a fun, yuck it up kind of thing. And they can get informal, but then when it's time for a net, they formalize it, and the nets are handled professionally. And it is a good name. Well, in like 7.6, basically we have just 2 rules: follow the Part 97 rules and talk on it as if you were talking to someone on the telephone. And I'll use an example. You wouldn't be on the phone talking to somebody and they say something and you wouldn't say, QSL 10-4. And you wouldn't say Roger, would you, on the telephone? The thing that we have a club have adopted is it's no CB lingo and no cutesy stuff like that, like the QSL. There are people who have this crutch. Every time, if they were on CB, they would end every sentence with 10-4, or they would start 10-4. Well, some of those people come over to ham radio now and they're saying QSL because they think that's, I don't know, 10-4 or whatever. It's an acknowledgement. So they'll say, QSL, Roger that, copy that. A lot of repeaters, not just this one, but a lot of them say, leave that alone. That stuff's for emergency use coordination, like we do when we're in tactical situations. But it's a good idea to monitor a repeater for a while, contact the repeater operator, look for information about the repeater online, or inquire with other hams before using a repeater extensively. And that's what 2.1 is. Tom is the guy who owns it, and he wants to know people. There are some people he would rather not hear on his repeater, and there are others that he welcomes. But that's his prerogative. It's his repeater. Now, how do they work? Let's get into that. Repeaters are not a whole lot different from the transceivers that you have. And it could be your walkie-talkie, it could be your mobile radio, anything. They're not much different from that. But there are a few specialized components that have been added to affect the repeat function with frequency pairs and to automate the repeater control. And we'll take a surface glance under the hood of this 57 Chevy here in a minute and take a look at a typical repeater. And there's a little block diagram that I have here to kind of show you how this works. In here, let's go around the clock. You see the duplexer, which is right before the antenna. You have a receiver that it sends a receive signals to, and it then goes through the receiver controller line. There's a control line and an audio line that goes to this magical box called the controller. A receiver, you pretty much know what it is because you already have one. So the only difference is these are separate boxes. They're not all one, except for one item, which we'll get to, called the crossband repeater. But here in a typical receiver, you have a receiver and you have a transmitter, and there's a control line that comes from the receiver. When it hears a signal, it triggers. I won't get into the details of it. It's a signal. It goes high, which will then go into the controller and pull in a logic circuit or a relay, depending on the manufacturer, and it will do what it needs to do to make that audio signal reach the transmitter and be retransmitted. But there's also a control line from that controller that I'll just say essentially takes the push to talk button on your radio and transmit on the repeater and does it. Not quite a push to talk, because there is usually no microphone on a repeater, but it's what it does. It puts the transmitter into the transmit mode, and it also sends the audio from the receiver into the transmitter, and then the retransmitted signal from the transmitter by way of coaxial cable makes its way to the duplexer. So you have it receiving, and at the same time it's receiving, it's transmitting too, without burning up the radio, because the duplexer does a little magic, which we'll get into here. This is what a typical 2-meter duplexer looks like. I don't know what you may have thought, but this is what they are. These are sometimes referred to as the cans because they actually look like a can. I don't have any cutaway views of these things, but they are a tube of a metal with what we call finger stock, and the screws you see up on top. I don't know if does my arrow show up on the screen? I hope it does. It's right now pointing at a screw connector. It's a bolt that's as long as that can is, and this round device, it's a piece of metal, usually gold iridite covered with gold-plated finger stock that'll slide down through that can, and that's your induction. It's cavity tuned. If you're thinking of induction as a coil, this has that effect too. And then there's another piece which this picture doesn't show. It's the coax, or it's the capacitive tuning, which is a trombone capacitor, which is essentially usually about a foot long, with a plunger of a dielectric that tunes it. So you're essentially tuning your inductance and capacitance in each one of these cans to do a specific thing. In the if you can picture and I had the picture, but I don't know what happened to it, of a sweep of a spectrum analyzer, but it shows on if you can think of the area where you got your signal coming in from the side, you got your signal coming in, and you got your transmit signal, and you got your receive. 3 of these are in line to the receiver, 3 are in line to the transmitter. Why 3? Because you need to have that dip be extreme when it comes to the receiver. It's got to be an extreme dip, and in the transmitter, it's got to be an extreme peak, because you want the transmitter to go out into the antenna, but the signal that's going to the receiver, you want to tune out that specific frequency that your transmitter's in. That's how you keep that receiver from ever seeing the transmitted signal. It's all done through these cans and the magic that there's in there. And also those cables are specific lengths to facilitate the proper tuning of them. And if somebody says to you, hey, I got a scope, I bet we can tune that duplexer. Don't let them touch your duplexer. If you own a repeater, don't let them do it, because it's very delicate to do. Now you see on this slide, the duplexers have knobs on those controllers, and then there's a little box beside the device, and that's where the capacitor typically hooks. And I don't think I have any pictures of them with the tubes. I know I have them in where I am, but to show them, this is a UHF duplexer. If you can picture this, it's 19 inches wide. It's got 4 cavities instead of 6, because we only have in the 2 meter, which we had here, you need a lot of rejection to keep that 600 kilohertz away. And these are big because of the frequency. In UHF, in the 70 centimeter band, are smaller, and you don't need as many because you're dealing with a 5 megahertz away signal than what it is. So it's easier to deal with. Now this is the owner of the 2-1 repeater, and he's showing you here. This is a repeater that he put in over in Mount Holly Springs on the mountain beside it. And what he's touching there is a controller. And you can see down the bottom, there are 4 cavities, 4 cans, all the way down there on the floor. This is a UHF repeater. They're smaller, and they actually fit in there. They look like they're, about 12 inches wide. So he's got less to deal with. And coming up from the cans, you have a transmitter and then a repeater controller and a few other things. Up here is at the very top is an amplifier for that repeater. Go on to the next one. This is an interesting one that he has. This is going up somewhere up in Perry County. This is a UHF repeater, and instead of what we've got here are 2 mobile radios. This is the way I built my first repeater back in the early mid 70s. I had 2 mobile radios that weren't even the same brand, but he got the same brand. These are Motorola radios. One receives and one transmits. They're 2 separate radios. We had one on 7.6. It was an ICOM pair, just like this, that one was transmit, one was receive. Being a 440 megahertz radio, check out the size of that duplexer. That one you can fit in your hand. It's if I stretch my hand out, I can put it over top of that. That's how little it is. This has 6 cavities in it. They're smaller cavities, but that's a mobile cable wave, cell wave actually makes this one. And they, I have one for a 440 repeater that's in the works. And this on top of that is a box that houses a controller. Everything can be small. It doesn't make it inexpensive, but this is, this is a way that we used to do them all the time. And that shelf that it's sitting on is a 19-inch wide rack shelf. And this, what looks like a computer power supply, really is not, but it's a 30 amp supply that a lot of people are using for their repeaters too. And this blew my mind. I think it's $20 or 15, something like that, but it's 30 amp supply. So there's a less expensive way to put a repeater up. And if you can find some radios at a ham fest that work, you can program them. It's good to have commercial stuff. You don't run them at their full output power though, because a lot of your ham radios are not made for continuous duty, meaning you can't take your microphone, click it in, wrap a rubber band around it and expect it to last more than about an hour before the heat overtakes it and shuts it off or burns it up. These are more a continuous duty because this stuff is commercial, and they know that they're going to burn them up if they don't make them durable. This is what a typical repeater cabinet looks like. At one of the broadcast transmitter sites that I take care of, there's one of these up there, and in it is a repeater for UHF. That's at 444.55. You can get that in the Harrisburg area. And this is a not a PAC RT. I've mislabeled this. This is the new radio the state police are using. This is what they've just been handed, and they're pretty cool. These PAC RT, let me go into that a little bit. There was a radio repeater that was available for the state police. It's still being used, only it's evolved considerably since I knew it back in the 70s and early 80s. The idea of the PAC RT was portable action something radio transmitter. They were in the trunks of the cars, of the cruisers. The police would, they always go out. They can't stand back at the car calling in unless you're Broderick Crawford on highway patrol. For those of you who are old enough to know what that means, but the police go out. They have a handheld radio on their belt, and they need help. They know that that isn't going to make it back to the headquarters, so their car becomes that repeater. And as other people pull in, second guy on the scene, they has his repeater on too. It'll automatically switch over to the last person who came in. It keeps doing that, and then as somebody leaves, it'll go back the chain again until it finds another radio that it can hook up as a repeater. Why the last person? I think that's typically because if they're doing a shift change or anything in an event, then they know that car is going to be there a while. And that's also why the police cars never shut off, because they got to keep this going. But now the new ones not only do that, but they'll also change, I think it's 4 different frequency bands that they work in. And that's what KNC is out now reprogramming all the police in the counties to go with this new radio. Pretty cool device. Now, I have 2 videos I'm going to show you. And while I'm getting that ready,
hello, YouTube preppers. This is the Comms Prepper, still at the retreat location in West Virginia. I'm getting ready to go up the mountain for dinner, and I thought this would be a good opportunity to field test the Ocean radio that I have with me and demonstrate the ADS SR1 simplex repeater. I've done previous videos about the simplex repeater in the past, but never really good field test. A lot of desktop demonstrations when I did those videos. So tonight we're going to try connecting the simplex repeater up to my base station, which is connected to the 6 dB gain whip antenna. And I've discussed the importance of having a good base station antenna. Handheld radios that you buy with that rubber antenna have absolutely no gain. In fact, there's loss, and that affects the performance of your radio. Well, with an external base station antenna, you can hook that up to your radio and greatly improve its performance. So we'll step in here to the Comms Prepper Studios and show you exactly what I'm going to do and get an idea how this is going to work. So I have a Yaesu FT2600M mobile radio, and I've turned the power down to about 10 watts. We don't need full power for this demonstration. Connected to the ADS SR1 simplex repeater here, produced by Argent Data Systems, and I'll put a link down below. And what's nice about this older radio is it actually puts power out through the accessory jack. So I was able to take the batteries out of the simplex repeater, and it's actually being powered by the radio, which is connected to this Yaesu base station power supply. Again, I have the Ocean radio. So what I've done is I've connected the base station up to the antenna that's outside, set it to a clear channel. Made sure I listened before I set this up. We don't want to interfere with somebody else. And I turned on a tone squelch, so interference won't trigger the repeater. That it's actually going to have one of those CTCSS tones before the repeater will activate. So I'll do a quick demonstration how this works here. I'm going to use the Ocean radio, and how the simplex repeater works is I transmit into the radio. The radio passes that transmission to the simplex repeater, which digitally records that audio. And when I'm done transmitting, this box will key or make this radio transmit, and it will repeat that message. So here we go for the local test, and then we'll go off the map and show you how this works from 10 miles away. This is Cape testing the simplex repeater, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, testing the simplex repeater. This is testing the simplex repeater, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, testing the simplex repeater. Okay, so what just happened there is I transmitted with the handheld into this base station, digitally recorded by the simplex repeater, and then the simplex repeater repeated that transmission that I made with the handheld out over the air. So what's going to happen is when I get downtown, I'm going to be over that ridge line over there, and I'll transmit up to this base station antenna, and it will record that through the base station on the poor man or simplex repeater. and rebroadcast it. So I'll be down in town in that valley, and I won't have near the amount of coverage I would from this location. So I'm going to transmit up from the valley up to this antenna, this base station here, and I'm going to get the advantage of being at this location and repeating that transmission as far as the eye can see above all these ridge lines. And if I had the radio at full power, this would probably go 100 miles. So I'm going to go ahead and pause here, and then when we get downtown, I'll show you how this works. Okay, guys, got off the mountain here, down here at the river, the south branch of the Potomac River, cutting through Hampshire County, West Virginia. And we'll do a quick check of the simplex repeater before we get through town. This is Cape testing the simplex repeater, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Testing the simplex repeater, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. So we can still hit the simplex repeater. We're down here in the valley at the river, transmitting all the way up there to the mountain up there, and the mountain's repeating that for us with the poor man's repeater or the ADS SR1 repeater. Okay, guys, we're at the restaurant, and we're going to check the simplex repeater here. We're about 9 miles from the retreat location, and we'll go ahead and call into the ocean radio and see if that repeater can pick us up from 9 miles away. This is Cape testing the simplex repeater, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. So there you have it, guys. That's the ADS SR1 simplex repeater, or the poor man's repeater, set up at the retreat location, providing enhanced radio communications, paired up with the ocean radio. And as always, thank you for watching my video and subscribing to my channel. This has been the Comms Prepper with a field test of the poor man's repeater.
Comms Prepper. So now I have more. There's another one. Simplex repeaters used to be made by Radio Shack. I have one, and they work well. You got to always use, when you put them up, have a tone on them, tone squelch. Don't put them on a frequency where everybody's going to be using them. Yeah, because somebody locally did it on 146.52, the national calling frequency, and got a lot of people upset. So now the other one is a portable repeater. Let's go to that one. Yes, here. And I'll do a share. Now, I'm sure you can all see that ammo box. All right, this is another use for an ammo box. Let's get him in here.
Hi, I'd like to take a moment to show you the ammo box TRP 8000 radio repeater. Available in both VHF and UHF, this unit is fully transportable and one of the only compact designed fully transportable units on the market today. Designed to be plug and play, the TRP 8000 runs from a simple 12-volt battery. Perfect for search and rescue teams, volunteer fire departments, emergency management, as well as industries such as logging, mining, and forestry. Here's what it looks like inside. The TRP 8000 consists of two TM8110 receivers. We have a receiver and we have our transmitter section. Inside is a ComProd mobile duplexer that acts to separate the transmitter and receiver and allows them to operate in full duplex. We also have our reverse polarity protection, and up here we have our power indicator and DC voltage meter. Here's how we connect the unit. It's very straightforward. We have our power connector. Power connector goes into the side. A battery input. Take this down. And we connect this to our battery using the alligator clip. Now, you may also connect this into your vehicle ignition system, car lighter plug. Reach up here, take our power switch, and power the unit on. As soon as the unit is powered on, we have our automatic voltage indicator telling us how much battery voltage we have, and our power indicator. One really cool feature of this repeater is reverse polarity protection. Let me illustrate how the reverse polarity protection works. First, we're going to turn the repeater off, as though we're clicking it up for the first time. Come over here to our battery, and let's pretend we've accidentally hooked our battery up in reverse polarity. Now, on most systems, this would completely destroy the units and completely destroy the repeater if you did this. But in this particular system, we have full protection against polarity protection. We're going to take the positive side of our wire and connect it to the negative side of the battery, and the negative side of the wire to the positive side of the battery. We have our indicator that's just come on the repeater, indicating that we have a polarity protection problem. But the best part of this is that we can take our power and actually turn our power on, and nothing happens to the repeater, thanks to the Texas Instrument module that protects us against reverse polarity. Connection for the antenna is as simple as 1, 2, 3. This is a very simple end connector, taking into an end female connector, a back end connector on the side of the TRP 8000. Simply plug it in, screw it on, and you're set to go. This connection can be made to any standard VHF antenna. In this particular case, we're using a magnetic mount antenna on top of the repeater. Very simple to put together, works real well. This antenna is a Larson WB150, which will give you plenty of range no matter where you go. Pop this on top of a mountaintop, and you're going to have 30, maybe even 50 miles of range off this one single antenna. The antenna itself is rated up to 150 watts. With minimal battery draw of less than only 1/10 of an amp and only 3 amps on high power transmit, this unit will last you all day on a fully charged battery. Full power output of 25 watts with direct line of sight, man, that will get you lots and lots of distance. Fully compatible with all makes and models of analog two-way radios, including Kenwood, ICOM, Tate, Motorola. You know, I'd like to thank you for stopping past and checking out the AMOBOX TRP 8000. If you're interested in our products, please check out our website at vhfrepeaters.com or simply email us at support@vhfrepeaters.com, and somebody will get back to you right away. Hey, you know what? If you like this video, please give me a thumbs up, subscribe to the channel, and thank you very much for visiting. Have yourself an awesome day.
And of course, the telling you what all it'll do. 90 dBm isolation on a small duplexer is kind of amazing. One, I guess I didn't say a whole lot about a controller. There's a lot of things that controller can do. It's an electronic device that's functionally interposed between the receiver and the transmitter, and it just makes the repeater work. It turns it on and off. It also, in the controllers, you can often have an interconnect to the telephone lines and other repeaters. You can have other receivers on the repeater all through that same device. Very often when they make them, they have a lot of different functions, and that's all by the, I guess, the manufacturers, whatever kind of cool things they want to put into it. But the typical ones are, you have to have control over your repeaters. So of course there's a knockdown procedure. You get somebody on there, you know, using foul language or inappropriate things, and they won't stop. You can bring that repeater down and then deal with the person another time. One thing I'll do very quickly, I don't have video to support this, but many of the receivers that you get now, the transceivers, have something in called crossband repeat. And what is it? What's its purpose? Whatever. I have one in my car, and I bought the radio specifically for that purpose because in emergency communications, you often have the need to have some way to talk to your portables, which might be down in another area, and you need to put something between them on a high spot. And the easiest thing is a crossband repeater. It will receive on the way crossband repeaters are made. It's it has to be, you're into the repeater on UHF and it can come out on VHF. Just one of those Part 97 rules that are probably still in existence, but that's why it does it. So they're quick to set up if your radio has it. Again, you have to make sure you run them on low power. Look up the Yaesu 8800. I guess it's an FT 8800. That's what I have in the car. In Dauphin County, we have ICOM 2720s, which also have that feature. And again, for that very purpose of if you're working an area where you can reach one place, you can go into simplex repeat or into crossband repeat. But the cool thing is you can arrange it to hit a repeater. So where our main comms are on 145.11 for an emergency in our case. But we have portables running around in an area that repeater can't hit, but it can hit a mobile unit that you have parked high in an area where it will reach that repeater. So that's why you have a crossband repeater in emergency communications, not just to be able to reach your portables as its own standalone repeater, but also to be able to reach an existing repeater and become part of that. So the only drawback of them is you have to wait for the repeater to drop for that to work. In other words, not just your mobile repeater. Your mobile repeater will drop instantly. But we're so used to jumping onto this repeater and not waiting for the signal to drop. And that would preclude somebody from coming in with a crossband repeater. The repeater must drop before it can continue. And you'll find on some of the repeaters, like the emergency stuff, that is a short tail and they'll drop. That's why. That's one of the many reasons why. So, and another thing you can do with repeaters is connect them to the internet various ways. The Internet Radio Linking Project, IRLP, is one of them. And you'll also find the repeaters hooked up with EchoLink and a few other different newer things that have come out since then. And those have their own protocol, but that's some of the things you'll find. Now, I hope that I was able to get you through a little bit more know a little more about a repeater and how they work. And the things that I'll say about the repeaters around here, we're lucky to have some that are owned by Dauphin County. And there's a procedure. If there's an issue with them, there are certain people who are allowed to report the problems. It's not something that the normal ham who knows of what's going on and says, okay, well, this has to be, I'm going to call Dauphin County. I'm going to urge you to not do that if you're so inclined. It has to go through one of several people. One is Gary Blacksmith in our case, and one is me, and no others. The Dauphin County people have a bad feeling about ham radio because there were some people that kept calling them and bugging them, and they're not in a position anymore, or never have been, to be able to be reporting problems directly to Dauphin County. And if you can understand, Dauphin County communications, where they take care of these things, they are busy people. They have our life and well-being to take care of when it comes to emergencies. That's why there are designated people to turn these things in. If it's a club repeater that has a problem, you might want to alert the board of the club or a member who has access to those people. And then just leave it at that. Let them handle the problem. And the same with county. Report it to the one of us who has the ability to report them the problems, and leave it at that. And don't be calling everybody to tell them that there's something wrong. So I think that's about everything that we can cover. And the ammo box guy, I like that. It's a device. All those parts are available. You can build your own. If you have the right tools, you can build one. And I like the ammo box because it's metal. The antenna sits on top of it, and it's its own little ground plane built into it. It's pretty cool.